morning children, and welcome back to your chemistry class. In this chapter of elements, compounds and mixtures, we have already studied about the elements, the compounds and the mixtures and their properties. Now today we shall study about the separation of the components of mixtures. So you already know that we need many substances to make our life more convenient and more comfortable, but most of the substances, they are available in what form? In the form of mixtures. So these mixtures, which also might contain the unwanted substances, and they can be harmful. They may even degrade the properties of the mixture. So for example, you can take like seawater. It is rich in common salt, which is an important ingredient of our food, and it also imparts good taste and it gives nutrients also to us. But this seawater cannot be directly used to get the salt. It is not that you go and drink the seawater and you are intaking the salt. It is necessary therefore to separate the salt from the seawater. Is that clear? So what is actually the purpose of separating, or what we are going to study today? The separation of components of mixtures. So why is this important is what we have to first understand, and then we shall go ahead with the separation of the components, right? So the purpose of separating the components, it is important because it removes some unwanted and harmful substances first and foremost. It also gives us pure and useful substance. Like in case of example that I gave you about seawater, what is the useful substance that we are getting? We get salt, which is very important in our day-to-day life. So we obtain the pure and useful form of that substance. So what is the principle of separation, or what does that separation that we are going to study today depends upon? So it depends upon the type of mixtures and their physical states. It also depends upon the shape, size and the color. It also at times depends upon the characteristic properties. Like for example, the separation depends upon the boiling point, the melting point of the substances that are present in the mixture. It may even depend upon the density of the substances that are present there, or maybe the solubility or the magnetic property, or even ability to get sublimed. So these are the different factors on which the separation of the components of the mixture depends upon. So in this chapter we proceed with the separation of components in what way? Like for example, we move to the first kind of separation, that is separation of solid mixtures. So today in this video I am going to only discuss about separation of solid mixtures. So what are the different methods for separating solid mixtures? First let us understand that, and then I am going to explain you all those methods. So first could be the hand picking, okay. Then second could be your magnetic separation. Then third could be your gravitation process. Gravitation method is also there. Then fourth could be, as I said, sublimation process, okay. Then fifth could be the solvent extraction method. Solvent extraction method. Then sixth could be like your fractional crystallization method, okay. So these are the 6 different methods that can be used to separate solid mixtures. But definitely all these different methods, they depend on the type of mixture and their physical states, right? So let us begin with the hand picking. What do we know about hand picking? Right? This method of separation, it can be used only when the quantity of mixture is small and the substance to be separated, it forms a small portion of a mixture. We cannot use a big portion of mixture. So the substances should always be enough in the size and of different colors. So what is important over here? What is the principle behind hand picking? That is, the substance should be large in size and of different colors. Okay, so this is actually the principle behind hand picking. Thus easily we are able to recognize the different colors, or easily we are able to recognize the large size of the particular mixture, right? So in that case we use hand picking. So example over here could be like, if you have ever seen mummy separating those small pebbles from the rice, right? The small quantity of rice is used over here. Now we do not use big quantity rice, small quantity rice which has to be prepared day to day. So from there small pebbles can be separated. If you have seen pulses, the yellow pulse, that is called as arhar. At times if you have seen, it has different colored other dals also, pulses present in it. So the color difference is there, size difference is there, and easily they can be separated. Okay, so over here the good example could be the small stones picked out from rice, then even pulses and even spices can be separated by this method. Clear? I hope this is very clear to you. Then next one, we come to the magnetic separation. Now for magnetic separation, one thing is very important, that one of the components of the mixture should get attracted by the magnet. Then only we can use this method of separation, that is magnetic separation. Is that clear? Like for example, iron, it gets attracted by the magnet and hence it can be easily separated from the mixtures. So if suppose there are number of nails spread out in your field, how can we separate? We hold a magnet and move around with it with the long rod. So what we will find, all the iron nails, it can easily get attracted by that magnet. Is that clear? So over here the best example is iron. So the principle behind this magnetic separation, the principle behind the magnetic separation is what? One of the components of the mixture should get attracted by the magnet. Clear? So you can see the irons, they get easily attracted to the magnet and they can be easily separated. Okay, so example could be like iron filings plus sand. Okay, so if you bring magnet over it, iron filings will be separated, sand will be left behind. Are these two clear? Now we next move to gravitation. Let's come over here. The third one, gravitation method. Now what is gravitation method? By this method this method is used only when one of the component is heavier than water and the other component is lighter than water. So what is the principle behind it? One of the component of the mixture is lighter than water and other is heavier, right? So what do? To the two solid mixtures we add water to it. Clear? So one of them will be lighter and the other one will be heavier. So what will happen? The lighter one is going to float in the water and the heavier one is going to settle down, right? So we can take example over here like sawdust and your sand. Sawdust plus sand can be used over here. So if you add water, what will happen? Sawdust, it is going to be light, it will float, and sand will settle down, right? And once the sand settle down, easily the water can be filtered, the sawdust can be separated out, sand will be left behind in the container. I hope gravitational method is also clear. Now the next method, that is sublimation. Now what do we know about sublimation? The process in which the solid directly changes into vapor form, that is called as sublimation. Clear? So that will also be the principle behind it over here. What is the principle behind? That one of the solid component, okay, directly changes into vapor form, right? Then we can use the method of sublimation. This method is used for solid mixtures, remember, in which one of the solid components has to directly change into the vapor form while the other is left behind, right? So example you can take over here like sand and iodine. What do you know about iodine? Iodine is a subliming substance, whereas sand will be left behind. Another example could be like if you take a common salt and NH4Cl. What do you know about NH4Cl? It is a subliming substance, whereas salt will be left behind, right? So these are some of the examples. Other subliming examples you may also write down. Subliming substances which are also called as sublimes could be your, say, camphor is also your subliming substance, naphthalene is also your subliming substance, right? So these could also be used in place of iodine or NH4Cl, ammonium chloride. So look over here. If I take a dish and I take, say, sand over here, right, and iodine. Suppose this is iodine and sand. So what I do, we take an inverted flask and plug it with cotton over here. This has to be kept on the wire gauge and place it on a tripod stand and start to heat, right? What are we going to see? We will see after heating the iodine. This is what iodine plus sand is present over here. So we will find iodine will vaporize. Iodine is going to vaporize directly into vapor state and it will collect at the cooler parts of the inverted funnel. Later, when the funnel cools down, we can scratch and remove the iodine and sand will be left behind in the watch glass. Clear? So this is one of the method of separating solid mixtures. Now next, coming to the fifth method, that is the solvent extraction method. Now, what is the principle behind the solvent extraction method? In this method, when one of the solid component is only soluble in the liquid, there are two solids, right? I add a liquid into it, only one of the solid it dissolves and the other remains undissolved. In that case, we use the method solvent extraction, right? So we write over here what is the principle behind. One of the solid component is soluble in liquid. Followed? So we can take an example over here like NaCl plus calcium carbonate. So now if we add water, what will happen? NaCl will dissolve, whereas calcium carbonate will be left undissolved, right? Then filter, remove NaCl, boil, water will be removed, NaCl will be left behind. So NaCl is separated and CaCO3 is also separated. I hope this is very clear. Once again I say, salt, it gets easily dissolved in water, while calcium carbonate, it is left insoluble. What will happen to it? It will settle down in the container. Then we are going to separate the two. Okay, and to obtain NaCl, what will we do? We will evaporate the water and NaCl. Water will evaporate, leaving behind NaCl. So NaCl and CaCO3 both are separated. I hope this method is also very clear. We come to the last method for today, that is by the fractional crystallization. Fractional crystallization method. So, what should be the principle behind fractional crystallization method? This method can be used when the solubility of both the solids is there in the liquid, but one of them will dissolve faster and the other will take little more time to dissolve. In other words, we can say that the solubility of the solid component of the mixture will be different in the same solvent. Clear? So, the principle behind fractional crystallization method is what? That when solubility of the solid components. Now here in solvent extraction, only one of them got dissolved, the other was undissolved. Sometimes you get such solid-solid mixtures that they both can easily dissolve in a solvent. Then in that case, what method has to be opted? Fractional crystallization method is to be opted, right? So over here, when solubility of the solid components of the mixture are different, in the same solvent. In the same solvent, the solubility of both the solid components will be different. So let's take for example over here, say I take NaCl plus KNO3. Okay, now what do we know about NaCl? You know that it easily dissolves in water. What do you know about KNO3? This also dissolves in water. So now when both of these solids they dissolve in water, then how are we going to separate the two? Here we are going to use the method by fractional crystallization. What? That one of the solids, the solubility will be different from the other. So let us understand over here. These both they are soluble in water, but the solubility of KNO3, that is potassium nitrate, is far more than that of NaCl. You must be thinking salt easily will get dissolved in water. But before salt can easily dissolve in water, which one will show more solubility to it? KNO3, potassium nitrate, will be more soluble, or will show more solubility will show a better solubility than NaCl. So when the solution containing the mixture of both NaCl and KNO3 and we add water to it, and KNO3 shows a solubility of which is more than NaCl, when we cool the mixture, this potassium nitrate, it is going to crystallize out first and will leave behind sodium chloride in the mixture, right? So KNO3 comes out in the form of a crystal. This will this is going to crystallize out, and what will happen with this NaCl? Still it is contained in water, so boil it, water evaporates, leaving behind your NaCl. Did you understand this point? I repeat the last one. When do we use fractional crystallization method? We use fractional crystallization method when both the solids, they are soluble in the same solvent. So over here, suppose I take an example of NaCl and KNO3. Both are soluble in where? Both are soluble in the same solvent, that is water. But then the solubility of one of the components should be more than the other. So which component is more soluble? KNO3 is more soluble, right? So this will dissolve first in water, leaving NaCl. NaCl will also dissolve, but it will take time. Before that, the solution, when cooled, the KNO3 will crystallize out, leaving behind NaCl. So this NaCl can be obtained how? When we evaporate water with NaCl, water evaporates, leaving behind NaCl. So this way we obtain NaCl and KNO3 by fractional crystallization method, where the crystals of KNO3 are formed. Clear? So today we do only the separation of solid-solid mixtures. Next time we shall come with the separation of solid-liquid mixtures. Thank you.